Picture this. You're sitting in the exam hall. The clock is literally ticking down. You turn the page of your Cambridge IGCSE 0625 physics paper and boom, there it is. A 6-mark multi-stage analysis question right on electrical safety. It reads, a 230-volt double-insulated hairdryer uses a 5-ampere fuse. Explain how the fuse protects the user and the appliance if a fault occurs, and evaluate why an earth wire is not required. Well, you know what a fuse is, right? You know what double insulation means. So you confidently scribble down your answer, you flip the page, and you move on. Fast forward to results day, and you scored a painful 2 out of 6 possible marks on that question. You're left thinking, no way, how did that happen? Why? Because knowing the raw physics facts and knowing exactly how to extract maximum marks from a principal examiner are 2 entirely different skills. Welcome to this explainer. I am the strategist, and today we are getting straight inside the examiner's head. We're going to master one of the most notoriously misunderstood sections of the syllabus, the use and operation of trip switches, fuses, fuse ratings, why outer casings absolutely must be non-conducting or earthed, and precisely how a fuse without an earth wire protects the circuit and cabling for a double-insulated appliance. By the end of this session, you are going to possess the exact blueprint to transform those 2 marks into a guaranteed 6. Okay, let's dive into this challenge.
To really understand how to win here, we first have to look at how most candidates lose. Let's look at the classic tension between 2 types of students. Let's call them Alex and Sam. Now, Alex has memorized the entire textbook. For that hairdryer question we just talked about, Alex writes, a fuse is a thin piece of wire that melts when the current is too high. This breaks the circuit. Power equals current times voltage. Double insulated means it has a plastic case. Okay, look, that is a classic knowledge dump. Alex overloads the answer with raw physics facts, but completely fails to analyze the specific context of the hairdryer. The examiner reads that and gives Alex maybe 1 single mark for identifying that a fuse melts. It's an absolute tragic loss of potential marks. Then we have Sam. Now, Sam is sharp, but Sam rushes. Sam spots the command word explain, but only actually answers half the prompt. Sam writes, the hairdryer doesn't have an earth wire because it has a plastic case, so the fuse stops you from getting electrocuted. Sam has missed the core physical mechanism entirely and made a fatal error regarding what the fuse is actually protecting in a double-insulated appliance. Both Alex and Sam lose massive points, not because they don't know the physics. It's because they lack an analytical framework. They completely fail to understand multi-stage analysis. They miss what we call the method marks. Those are the points awarded not just for the final correct statement, but for demonstrating a clear, logical, step-by-step process of reasoning. The real tension here is that you can know the 0625 syllabus inside and out. But if you don't decode the command words and structure your answer precisely how the examiner's mark scheme dictates, you are leaving the easiest marks on the table.
So, how are we going to fix this? Here is our roadmap for today. First, we'll lock down the core safety principles. Second, we're going to uncover the examiner's trap. Third, we'll deploy the method mark strategy. And finally, we will break down the deconstruct, solve, and evaluate framework.
Let's start with part 1, core safety principles and building the foundation.
To absolutely conquer this exam, or honestly, any Cambridge physics variant like 0651, 0652, 5054, or 9702, you have to understand the assessment objectives. The exam isn't just testing your memory, it's testing your cognitive domains. AO1 is knowledge and understanding, right? Like, can you define a fuse? AO2 is problem solving. Can you calculate the correct fuse rating for a specific appliance? But AO3 is where the elite students separate themselves from the pack. That's analysis and evaluation. You have to explain the causal chain of exactly why and how safety devices work. Here's your baseline syllabus requirement. A fuse is an electrical safety device. It consists of a sacrificial piece of wire designed to literally melt and break the circuit if the current exceeds a specific predetermined value. That's its rating. A trip switch or miniature circuit breaker performs a really similar function, but operates electromagnetically or thermally to mechanically break the circuit. A major difference, it can be reset, whereas a blown fuse has to be entirely replaced. Now, the fuse rating is absolutely crucial. If an appliance normally draws 4 amperes, a 3-ampere fuse will blow continuously during normal operation, which is useless. But a 13-ampere fuse, that might allow a dangerous 10-ampere fault current flow without melting at all, leading to overheating and potentially a house fire. The correct rating is typically just slightly above the normal operating current, like a 5-ampere fuse for a 4-ampere device. Now, when you explain this in an exam, top students use what we call the PEEL framework, Point Evidence Explanation Link. You make your point about the fuse, you provide evidence, like calculating the normal operating current using P equals I times V, you give your explanation of the melting wire breaking the circuit, and finally you link it back to the context, which is protecting the specific appliance from a fire hazard. Mastering these definitions and pairing them with the PEEL framework is your absolute first step to unlocking the examiner's mark scheme.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along, what's really interesting here is the critical distinction between earthed appliances and double-insulated appliances. This is a super common area where students just bleed marks. Think about appliances with a metal outer casing. A toaster, a washing machine. They present a unique and terrifying danger. If the live wire inside becomes loose and touches that metal casing, the entire outside of the appliance becomes live. If you touch it, the current flows right through you to the ground. That's a fatal electric shock. To prevent this, these appliances absolutely require an earth wire. The earth wire is a very low-resistance path connecting the metal casing directly to the ground. If a fault occurs, a massive current surges through the earth wire. This immediately exceeds the fuse rating, blowing the fuse in the live wire and isolating the appliance, keeping you safe. Conversely, we have appliances with an outer casing that must be non-conducting. We call this double-insulated. Think of a plastic hairdryer or a plastic electric whisk. If you look at the plug or appliance, the symbol for this is a square within a square. Because the casing is an insulator, even if a loose live wire touches the inside of the casing, the exterior cannot become live. Electricity won't flow through the plastic. The user is inherently protected from electric shock by the casing itself. Therefore, a double-insulated appliance simply does not need an earth wire.
And that brings us to a brilliantly subtle point in the syllabus. This is the exact thing that catches thousands of students off guard every single year. If a double-insulated appliance protects the user from shock because of its plastic casing and it doesn't have an earth wire to trigger the fuse in the event of a casing fault, why does it still have a fuse? I mean, really think about it. Listen closely because this is an exact syllabus requirement. A fuse without an earth wire protects the circuit and cabling for a double-insulated appliance. Imagine a short circuit occurs inside that plastic hairdryer. Say, the live and neutral wires touch each other directly, completely bypassing the motor. The resistance drops to almost zero. According to Ohm's law, current equals voltage divided by resistance. A massive surge of current will instantly flow through the power cable from the wall to the hairdryer. If there were no fuse, this massive current would cause the cable to heat up dramatically due to I²R heating. The plastic insulation around the cables would literally melt, and it would start a devastating electrical fire right in your home. So the absolutely crucial point you must remember is this. For a double-insulated appliance, the fuse is there to protect the internal circuitry and the external power cabling from overheating and catching fire due to a massive overcurrent. It is not relying on an earth fault to blow. You must state this clearly to get the mark.
All right, let's pivot to part 2, the examiner's trap and the top 3 mistakes candidates make.
I've combed through years and years of Cambridge Principal Examiner reports. These are the official documents where the people grading your papers vent their absolute frustrations about what candidates constantly get wrong. Reading these is literally like having the opposing team's playbook. When you understand exactly where others needlessly lose points, you can systematically engineer your answers to avoid those traps entirely. Let's break down the top 3 errors. Mistake number 1, forgetting proper format. In physics, format means showing you're working logically. If the question asks you to determine the right fuse, you don't just write 5 amps. No way. You write the formula first, P equals I times V. You substitute the values, I equals 800 watts divided by 230 volts. You state the calculated current, 3.47 amps. Then, and only then, you make your conclusion. Therefore, a 5 amp fuse is required. Those red pen marks from the examiner will transform into green check marks if you just clearly show the steps. Mistake number 2, failing to check presentation. Look, I know this sounds incredibly basic, but examiners note that illegible units or failing to clearly separate the stages of an explanation cost students an average of a full grade boundary over an entire paper. A full grade boundary. If you are explaining a multi-stage process, like a fault occurring, the current surging, the fuse melting, the circuit breaking, use bullet points or clear sequential sentences. Make it impossible for them to misread your genius. Mistake number 3, and honestly, this is the big one, providing answers that are not specific to the context. Let's look at exactly how we fix this.
This quote on screen is a direct examiner alert. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Let's look back at Alex's original flawed answer from the beginning of our session. Remember, Alex wrote a super generic definition of a fuse. The transformation happens when Alex rewrites that answer live using the PEL framework and explicitly applying it to the context. If we were to rewrite Alex's answer right now to grab all those marks, it should look exactly like this. Because the hairdryer is double insulated with a non-conducting plastic casing, the user is protected from electric shock. Therefore, no earth wire is needed. However, the 5-amp fuse is required to protect the appliance's circuitry and the main power cable. If an internal short circuit occurs, a massive overcurrent will flow. This current will exceed the 5-amp rating, causing the wire inside the fuse to melt and break the circuit, which prevents the cables from overheating and starting a fire. Do you see the difference there? The red pen turns green immediately. Every single point is tethered to the hairdryer, to the casing, to the cable, and to that specific 5-amp rating. That is what top mark potential looks like. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's move to part 3, the method mark strategy and earning points for your process.
In Cambridge mark schemes, you will often see a capital M right next to a point. That stands for method mark. It means the examiner is explicitly instructed to award you a mark for a logical, structured, analytical process, even if you make a completely silly arithmetic error on the final line. If your process is inevitable, you get 0. If your process is explicit, you capture those points. Here is the strict 5-step procedural framework required to execute this methodology effectively. Take a mental screenshot of this right now. Step 1, identify key elements. Scan the question. What are the givens? Voltage, power, is it earth or double insulated? Step 2, apply relevant principles. Which physics rules apply here? Ohm's law, the heating effect of current? Step 3, execute analysis with clear working. Write the formulas out. Substitute the numbers in. Step 4, verify results. Does a 13-amp fuse make sense for a tiny phone charger? No, obviously not. Check your logic. Step 5, present an appropriate format. Use that Peel framework we talked about. Let's do a quick mental data scan challenge. I want you to imagine a complex data table showing the response times of various trip switches at different overcurrent levels. Let's put 60 seconds on the clock in our minds. What is the core trend you are looking for? You extract the key elements. You realize that electromagnetic trip switches break the circuit in milliseconds for massive short circuits, while thermal trip switches take slightly longer for gradual overloads. You interpret that relationship. This is the structured, calm thinking examiners desperately want to see.
Now, here is a phenomenal insider tip drawn straight from our examiner sources. Integrating safety principles with other syllabus areas demonstrates the analytical depth examiners crave. When you discuss a fuse melting, you are obviously dealing with electricity. But if you briefly reference the thermal physics involved, specifically that the high current causes I²R heating, which raises the temperature of the fuse wire until it reaches its melting point, changing state from solid to liquid, you are showing incredible cross-topic mastery. Let's try another interactive challenge right now. We'll call this Find the Flaw. I am going to read a sample student paragraph, and I want you to mentally identify the exact sentence that is losing marks. Ready? The metal casing of the washing machine is connected to the earth wire. The earth wire reduces the current if there is a fault. When the live wire touches the case, the fuse blows. Okay, time's up. Did you catch it? The earth wire reduces the current. That is a massive, fundamental conceptual flaw. The earth wire absolutely does not reduce current. It provides a very low resistance pathway that actually causes a massive spike in current to ensure the fuse blows instantly. Recognizing these really subtle physics mechanics is mandatory for executing your methodology flawlessly.
Strong data interpretation skills are just critical here. If an exam question provides a table of standard fuse ratings, say 1 amp, 3 amps, 5 amps, and 13 amps, and it asks you to select and justify the appropriate fuse for a 1200-watt vacuum cleaner running on a 240-volt supply, you must systematically execute the process. Let's do a 30-second speed writing simulation. Imagine a timer counting down. Mentally draft your perfect Peel paragraph. Point. Choose the 5A fuse. Evidence. Calculate the current. I equals P divided by V. That's 1200 divided by 240, which equals 5 amps exactly. Explanation. A fuse must be rated slightly higher than the normal operating current to avoid blowing under normal use. Wait, if it's exactly 5 amps, a 5-amp fuse might actually blow during the initial power surge when the motor turns on. Link and revised conclusion. Therefore, the 13-amp fuse is the safest appropriate choice from the table to allow for the starting current while still protecting the cabling from massive short circuits. Drawing that kind of highly nuanced, evidence-based conclusion from the data provided separates an A-grade candidate from an A-star candidate every single time.
Finally, let's round this out with Part 4, Advanced Problem Solving. Deconstruct, solve, and evaluate.
If you truly want to secure those final elusive marks on the absolute hardest questions at the end of the paper, you need to transition your brain from a descriptive mindset to an evaluative mindset. It's not just about describing what a safety device does anymore, it's about evaluating why it is the best solution for the specific scenario presented. This is your final cheat sheet framework, the 3 rules that guarantee top marks. First, command word decoding, which leads to deconstruct. Strip the question down to its raw variables. Separate the distractor information from the core physics. Second, peel framework application, which is how you solve. Systematically apply your formulas and your peel paragraphs. If the command word says calculate, you show numbers. If it says explain, you show the causal mechanism step by step. Third, time management matrix and evaluate. Check for reasonableness and justify recommendations. If the question asks you to compare a trip switch to a fuse for a household lighting circuit, don't just say one is better. Evaluate the alternatives. A trip switch is way more sensitive. It reacts faster and it can be easily reset without replacing parts, making it significantly safer and more convenient for domestic use compared to a traditional melting fuse. You are defending your physics approach with structured evidence.
And this brilliantly illustrates what it means to be a top-tier student. True mastery goes far beyond merely reciting descriptive answers from a textbook. When you evaluate, you are showing the examiner that you understand the real-world application of the physics. You understand that a plastic outer casing is an assumption of safety, but that assumption only holds true if the internal cabling is still protected from overheating by a fuse. You consider the perspective of user safety versus appliance protection. You justify exactly why an earth wire is totally useless on a double-insulated device, but absolutely critical, life-saving even, for a metal-paste washing machine. This level of analytical depth is what the principal examiner reports are quite literally begging to see. When you write with this level of clarity and structure, you don't just hope for marks, you command them. The examiner can clearly see your thought process, and your methodology becomes completely bulletproof.
So, here is your final provocative challenge. The next time you sit down with an 0625 past paper, I want you to actively test this examiner mindset. Don't just write down the very first fact that pops into your head. Pause, look at the command word. Think about the tension between Alex's scattered knowledge dump and Sam's rushed execution. Apply the peel framework, deconstruct, solve, and evaluate. How will you use this exact methodology to ruthlessly extract every single method mark available? Take this playbook, execute the strategy on your next past paper, and approach your exam with the mind of a principal examiner. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.